Hello. So this session is going to be in English, but feel free to ask questions at any time, both in English and Chinese. So before I start, I really want to say thank you for staying until the last minute, because when I received the schedule, I was literally having to scroll down to the very bottom to see my session. And I was really worried that I'm going to face an empty room. So thank you so much for being here. Today I'm going to talk about smart workloads, automated routing, scaling of Kubernetes and serverless functions. So a lot of buzzwords, as you can tell from the title. And there are a lot of more to cover, like edge computing, smart workloads. And myself, my name is Enlin. I'm an engineering director at Turbonomic. I'm pretty sure not many people heard about Turbonomic. So we are a company actually based in Boston, founded in 2009. Myself is based in New York. So we feel very lucky to be here because compared to a lot of presenters in this conference, we are a much smaller company. We have around 500 employees, and the whole company is founded on the idea that the software should manage IT resources, not people. So we have been awarded the 2018 Cloud, the world's most best 100 cloud companies in the world, and we are growing really, really fast. So that means we're hiring. So if you're interested, just contact me after this session. So if you're interested in this presentation. So also, you may notice that I posted a Twitter from Kelsey Hightower. So I'm pretty sure that Kelsey is much more famous than our company in Kubernetes community. So the reason is why I post his Twitter here is because what he says here, here's my application, run it for me, when and where I want it, securely, that's the end game. That's exactly aligned with what our software is trying to deliver. The value we are trying to deliver is that we help you to automate the IT management for people using software instead of people. So that's the end game. So people, developers have the dream that they want to run application anywhere, but how to operate these applications, whether it's a virtualized application, containerized application, serverless application, whether it's a cloud infrastructure, on-prem infrastructure, how do I manage it? This is exactly what we are trying to solve. So we have over 2,000 world-class companies that trust Turbonomic across different industries. So without saying much about my company, here's what I'm going to cover in this session. So first, I'm going to introduce what is the challenge to deploy and operate applications in the cloud. Then I'm going to talk about what is the concept of smart workloads and what is the concept of edge computing, and how the smart workloads in edge computing look like. And a large portion of this session is going to be a demo. So we create a test bed that actually combine a lot of technology together. That's a really cool test bed, as you can tell later, that we want to show you, and we're going to break down these technologies and show you one by one and how this a smart workload in edge computing will look like and how smart they can be. And last but not least, I'm going to summarize with a few key takeaways. So, as I mentioned, during the session, feel free to interrupt me if you have any question. So, challenge. I want to run some code in cloud, and so things are always more complex than you thought. So, even if you want to run some workload in cloud, it's maybe easy in day 0, but definitely not easy in day 1, day 2, and on beyond. First of all, in day 0, you may want to consider about the operational complexity. Whether you want to package it in a virtual machine, which you have to configure the machine, the OS, the storage, the network, or you want to configure the container, in which you still need to configure the application itself, the sizing, the scaling, how to automate the scaling, things like this. And serverless, still you have to configure the memory configuration, where to run, whether you want to run it on a cloud serverless platform, or you want to run some Kubernetes-based serverless platform like Knative, OpenWhisk. And then in day 2 and day ongoing business, you want to consider the capacity management. Even the cloud has infinite capacity, but that's not your budget capacity. You don't have infinite budget. And scalability, you always want to infinity scale your applications, but you only want to pay for what you really need. So you want a highly scalable cluster with highly scalable workloads that always automatically scale in and out so that you don't pay extra for what you need. So you may easily reach to a conclusion that serverless seems like the easiest way to deploy applications, or is it? If we take a look at the serverless use cases, for example, an image upload to S3 triggers a Lambda to compute a thumbnail to post on Twitter. I'm not going to read all this aloud, so you can easily find a few serverless use cases. So by looking at these use cases, you can easily tell that the first complexity comes in the fact that serverless application itself, the serverless function itself, doesn't have to be the only component in the application. So usually, the application itself is a hybrid application that is composed of serverless function, some database services, some other services either running in container or VMs. So what you are facing, the first challenge is the complex serverless chains that you may have multiple serverless functions that connect to your RDS or connect to your DynamoDB. And if you don't have a well-operated serverless configuration, you may face troubles because of this cascading effect. And then what about the challenging day two operations? So what if the functions aren't properly sized? So when undersized, you will face some high response time. When oversized, you will face some unnecessary high cost accumulates. So if you actually deploy everything on the cloud, they are charging you based on the memory sizing. So if you oversize your function all the time, then you're facing extra cost. And then it's also possible that you may face some cross-region data transfer cost, which is also going to be severe, even if you think that serverless should be very, very cheap. So the solution may be you should be placing this Lambda function in every region, but still, you should be able to have the capability to reroute the traffic to a different region in case it will cause some high cross-region data cost. And then, if you actually choose not to deploy your serverless application in the cloud, instead you want to deploy your serverless application anywhere based on Kubernetes platform, for example, Knative, OpenFaaS, OpenWhisk, then you may face the same scenario that you face for containerized applications or virtualized applications, that you may face the performance degradation due to the underlying infrastructure resource congestion. So in this case, the solution can be scale cluster or reroute the traffic to a different cluster, which is the traffic engineering. So in this session, in fact, we build a testbed, which is to showcase this reroute of the traffic between different platforms, one deployed on the edge, which is a Knative serverless platform, and the other deployed on Lambda. And when you have the resource congestion happens on the Knative platform, we automatically route your traffic to the Lambda function that serves the same function. So this is exactly the demo I was just talking about. So smart workloads with edge computing. So edge computing has become a harder and harder topic. So in fact, this morning, the KubeEdge has announced that they are going to be open sourced. So that means that edge computing is actually not very far away from us. So what does edge computing mean? That means that you are moving intensive workloads from the cloud out to the edge of the network. So edge computing, as you can tell, it will be highly valuable if you're actually running a lot of IoT workload. So we have heard a lot of hardware vendors that start to thinking about deploying their data center instead of in different regions, like 50 different regions in the world. They're considering to deploy their data centers in the cell tower. So imagine the intensity of how many cell towers you're going to see, and all of them will be equipped with data center. So when you actually are driving a car, when you're stuck in the traffic, you try to reach some server-side application from your client, from your mobile device, instead of reaching to the cloud, you may actually served by a server that is deployed at the edge computing side. So edge computing is really, really cool. And what is smart workloads? Smart workloads here we define as these easy to place and size. They're short-lived, they're very small. There's no need to continuous placement. You don't have to move this workload. You don't have to migrate this workload. So it's one-time placement, and the size is usually small. And it should be traffic engineering capable, means that it's stateless. We don't consider in this demo, we are not considering if they're actually trying to get a lot of data from the data, that you have to consider how much data is cost and how far you're away from the data. So this is not, we are considering a smart workload. So stateless workload is also an important criteria here. So multiple instances of the same function can be placed across different clusters, different regions, different edges to satisfy the client request. So, as I mentioned that we are going to start the demo. Most of the part of this session is about going through the demo. So I hope that you can enjoy this demo breakdown. So first of all, to create this simulation of edge computing versus cloud, we first choose to deploy the cloud serverless platform, and the choice we choose is the Knative platform, which is I wonder how many of you have heard about Knative? Great, thank you. So Knative is a platform that is actually announced by Google this year. So it's some pretty cool things, which we believe that it will be a new standard for run serverless workload on Kubernetes. So we actually, in the beginning, so anything you see here, Knative or Lambda, they can be swapped by any other serverless platform. So this is really just for proof of concept. So initially we use OpenWhisk, then we think Knative is so cool, so we decided let's play with Knative. So we deploy a serverless platform, Knative at the edge, and then AWS Lambda in the cloud. And within these two platforms, we actually deploy the same applications, one in Knative and one in AWS Lambda. On top of that, we have deployed some API gateway called Con. So again, this Con can be replaced by any other API gateway, like Gloo, for example, another cool startup in Boston area that they develop some API gateway similar to Con. So the purpose of having this API gateway is that you can easily configure some static routing between Knative and Lambda so that when we actually push the policy through Istio, then go through this Con, it knows where to route this traffic to. So some of the people may ask, so you can imagine that I just mentioned Istio. So Istio is another routing layer on top of that. So since Istio is becoming very hot, so why don't we add Istio into the picture as well? So Istio here serves as a policy enforcement tool. So basically, in this demo, we're using the label-based policy routing to actually push the routing data to Istio so that we can routing the client based on the label. If it's a label full, it goes to the Knative. If it's a label bar, it goes to the Lambda. And the reason why we need Con here is really because Con has a very good integration with a lot of serverless platform that to save some time to building this testbed, we actually choose to integrate with Con instead of writing some extra code to use Istio only. But Con is actually not a necessary part in this whole demo picture. And then we have the client start to visit Istio. So what we want to create the scenario here in this demo is that the client keeps calling Istio, and then they get routed, some of the client routed to Knative if the label is full. And when the Knative itself is built on Kubernetes cluster that is at the edge. Okay, so that means that you can actually monitor the resource consumption at the Kubernetes level. And what we have here is that the resource gets congested at the edge, and the response time of the same application that is satisfied from Knative and AWS Lambda, they differ a lot. So the Lambda gets a much better response time application performance, while Knative, because of underlying infrastructure congestion, they're getting a very poor performance. So what we do here is we actually use Turbonomic, which is our company that is actually serve as a decision-making engine to help you automatically choose the routing based on this. So in this case, we identify that there's a resource congestion in Knative, and there are same function at the different edge or different cloud that you can actually satisfy the same client. So we will route the traffic from Knative to AWS Lambda. So a little bit breakdown with more details. So the serverless platform, as I mentioned, that you can actually choose any of the flavor in this diagram. So we choose one from the cloud, we choose one from the Kubernetes-based serverless platform to showcase. So we believe that if you actually deploy the edge computing, it must be depends on the Kubernetes. So it must be the Kubernetes must be the infrastructure abstraction. So Knative, we love Knative a lot, so we picked Knative as the showcase. But again, you can pick any of the flavor in this picture. And then API Gateway is really a glue that actually combine the Lambda with the Knative so that we don't have to write extra code to make the Istio directly routing to Lambda or Knative. You just need to have some static mapping configured in Con that will serve the same purpose. And I will show you with more details in the demo. Then the routing layer, which is the Istio part. So the service mesh, so just a brief introduction about service mesh. So service mesh, there are a lot of definitions about what is service mesh. One of my favorite definitions is that when microservice overlaps with the network functionality, that's where the service mesh starts to play his role. So for example, telemetry, authentication, security, all these kind of things where microservice wants to overlap with the network. Now service mesh takes the control of how everything should work. So there are a lot of functionality that service mesh or Istio can provide: telemetry, policy enforcement, traffic engineering. So here we basically take advantage of the traffic routing functionality of Istio to finish this demo. So here you can see this YAML file, which we actually create a virtual service object, which and create a rule in this rectangular box. So the rule is very simple. So if the app has the label full, then it goes to the hello Knative. If the app has the label bar, it goes to the hello Lambda. And last but not least is the decision-making engine. So we want to make sure that the decision can be made in different aspects. So in this case, in this demo, the decision is made by if the application performance has been degraded or not. And the degradation can cause by the underlying infrastructure congestion. So the decision making you need to make in a day-to-day basis, including scaling, capacity, placement. So in this demo, we're focusing on the placement. So I know this session is not supposed to be a vendor pitching, but I really want to just give you some introduction about how this Turbonomic works in the back, which I think is a pretty interesting idea that I want to share with everyone. So the secret ingredients why so many customers is using Turbonomics, because we create an abstraction, which is the most important layer of our system. So regardless what kind of infrastructure people are using, whether it's on-prem or cloud, regardless what type of application people are using, application, VM, or containers, we actually create an abstraction layer. So abstraction is the most important thing in the data center. So in fact, one of my favorite KubeCon presentation is delivered by the CTO of Box, Sam Gold. He actually mentioned one of the biggest benefits of Kubernetes itself is that it creates the abstraction that abstracts away the complexity of underlying infrastructure, so that you don't have to configure persistent volume, load balancing differently because you choose different infrastructure. So having Kubernetes, it actually abstracts away the complexity and simplifies the operation because you only need to know how to operate on Kubernetes. The same concept applies here. So Turbonomic actually creates the abstraction which abstract away different entities like apps, container, VM, physical machine, fabric. They are all service entity in our model. And then every single resource, CPU, memory, flow, IOPS, latency, large page, GPU, any kind of resource you can think about, or any kind of constraint like label, selector, affinity, anti-affinity, taints, toleration, they're basically commodities. And service entity will buy and sell commodities. So the interesting part is that on top of this abstraction, we apply economic theory. So since we talk about commodity, so commodity is like our real life commodity, right? Every commodity will be associated with a pricing function. So the pricing function of this commodity is the higher the utilization of the commodity, the higher the price of the commodity. So as I mentioned that every service entity in this market is basically nothing but a trader. So we don't care if it's a container, it's a pod, it's a load balancer, it's basically a trader that buys and sells commodity. So the fancy part of this algorithm, the elegant part is that every trader makes their own decision about their sizing, scaling, and placement decision by themselves. So it's a highly distributed algorithm that, for example, if I'm a virtual machine, I buy CPU memory from a physical server, that will be my expense. And if I find another physical server has a much cheaper bundle of CPU and memory, I will move myself to another physical machine. That will generate a move action from one physical machine to another physical machine naturally. Same time, if I'm running Kubernetes service, I have some application that is highly utilized because I'm hitting a lot of transaction and revenue transaction and response time. That is generating revenue for me. And if my underlying infrastructure is not so expensive, that's my expense. My ROI will be high enough for me to expand my business, and I will clone myself. That generates a provision action. On the other side, if I'm not making enough money while the underlying infrastructure is congested, I may easily go bankrupt and cause a suspend action, scale in action. So everything in this model is so elegant that every trader itself is making their own decision of scaling, placement, and sizing. to achieve the best return on investment. So everything is economic principle driven. So far, so good? Oh, sorry, doesn't. So after this analysis engine, the output of this decision-making engine, Turbonomic, is basically provide continuous optimization in real time that drives continuous health on placement, sizing, provision across different layers of your IT infrastructure. So container, pods, VMs, every layer, every entity is making their own decision based on the economic theory, based on the economic principle to achieve the best ROI. So they will try to place in a cheaper place. They will try to size up or down based on their ROI. They will try to provision or scale based on the ROI as well. So on top of that, we also provide the capacity management, which give you the capability to create a what-if scenario sandbox so that you try to create actual workloads, try to replace your hardware, try to migrate to cloud, or the scenario you may face that you want to change your data center in the future, you can use this sandbox. In reality, in the back of this application, all we does is basically adding supply or adding demand and simulate the whole market behavior and let the market play the magic itself. So everything is very, very consistent. So now, demo time. So I will just, so let me go back to this slide. So I'm going to show you every layer one by one in this demo. First of all is the serverless platform layer. So we use Lambda and the Knative, and we have the Knative built in my Kubernetes cluster, and I hope the network actually works well. So in both platforms, we have this cool app defined in both the Lambda as well as the Knative platform, which is running on one of the Kubernetes cluster. So we consider this Knative as one of the data center that running at the edge. So both applications serves the same purpose. So this cool app is so cool that all it does is basically echo a message to show where you actually get the server response from. So if you actually get the response from Knative, you'll get the message like hello from Knative. If you get the server response from the Lambda, then you're going to receive a message like hello from Lambda. So this is the serverless layer that you have both applications running on both platforms. Then the API gateway layer. So if we look at the API gateway layer, so you can see we have deployed the Con pod as a replica controller. And what Con does, if you can, so as I mentioned that the only reason why we try to use Con is because it actually provides a static routing that help us to easily map the core to the corresponding function deployed in two places. So if I show you how everything configured in Con, then from the route side, you can see that we have two different passes. One is cool app in the cloud, which is corresponding to this service. The other is cool app at the edge, which is corresponding to another service. And if you do the same query, if you do the same query on the service side, you can see that the first service that we talk about here, if you map the ID, that will be the Lambda service. The second is basically mapped to the Knative service. So all it does, this Con, is easily so that you don't need any code change. For us in this demo, all we want to show you is a proof of concept of how everything works. So Con is not the most important component here. All it does is just a static mapping about how this routing based on URL works. So Istio part, that is the interesting part. So we do create a virtual service object in the Kubernetes cluster, as I mentioned in the slide. So all it does is to specify the routing rules. So as you can see, so one second. So basically the client side, from the client side, all it does is trying to make an API call on the endpoint cool app. So they don't have any idea about whether this cool app will be satisfied by the server running on Lambda or by the server running on Knative. So all it does is to trigger a request to CoolApp. So what happened behind the scene from the Istio perspective is that Istio checks whether this client has a label foo, then it overrides the URL. Instead of CoolApp, it actually overrides to CoolApp at the edge. And for the label with car bar, instead of CoolApp, it overrides CoolApp in the cloud. So having said that, after this rule, whenever you receive a request based on the label, it will automatically override the URI. After that, there is no ambiguity that Con knows that where exactly to route this traffic. So what does that mean? That means that what the decision-making engine, Turbonomic, is going to do is that it's going to manipulate the label based on the foo or bar to actually manipulate the traffic. So it can always override the client label so that it will map to exact URI to map to the traffic. So how does everything look like? So if I do a curl from one of the pod in this Kubernetes cluster with label foo, you can see you will get the hello from edge. And if you actually run another curl from an application that with label bar, you are going to receive hello from the cloud. That's the setup. So now the decision-making engine. So that's the Turbonomic part. So I'm not going to show you a lot about Turbonomic because if we want to do a deep dive, it will take a long time. So just a little bit overview of how this Turbonomic look like. So the entry point of Turbonomic is basically user count here as the target configuration page to tell us what kind of data center you have. As you can see, this is pretty much the prerequisite to let any decision-making engine happen, because first step is to understand your topology, your resource consumption, everything from your data center. So we do have all these kind of technology supported out of box. You can add these things from hypervisor to cloud native, everything that you can find like Kubernetes, Knative, Prometheus out of box. You can just add them. We use the APIs, we support with the API, and if you don't actually see the flavor you're using, which is quite rare, in our target configuration, you can actually use our open source Go SDK to support it yourself. It's not so difficult. So having said that, we add all the things that we covered, like including AWS, Lambda, Kubernetes, Knative into Turbonomic. So immediately, you're going to see the full stack visibility that combine everything together. So you may see partial view from either of the technology I described. But by having all the data coming to the same platform, i.e. Turbonomic, that we are able to identify which are the entities that are actually common to the platforms, that we will merge them together. So with that, you can actually see the full stack visibility, like from your services running in Kubernetes, your Knative application running in Kubernetes, all the way down to the VMs running on AWS, things like this. And with the decision-making engine, you can see all kinds of actions that are recommended by Turbonomic. For example, you want to move a volume in AWS, you want to move a container pod in your Kubernetes, which is actually another functionality we provide, because placement can happen every layer, right? So whenever you find a cheaper placement, you will move your container pod to another node in the same cluster. So all these scaling moving can happen with our analysis engine. So I'm not going to cover a lot of details about all these decision-making engine. So let's focus on the Knative part. So we basically, the Knative serverless function in here, in our data model, it's called virtual application. So you can see it is running in one of the pod in Kubernetes that is in one of the Kubernetes cluster on top of an AWS cluster. So this is how everything's set up. So as I mentioned, that since you add all these targets in Turbonomic already, so we are able to give you a stitched full stack visibility in a single pane of glass. So what happened here is that you can see this Kafoo, which is the application that running on Knative, is actually suffering from the performance, which is because the virtual machine that is in this cluster is heavily congested. If you look at the virtual machine that currently hosts this Knative, you can see that the virtual memory is heavily congested. So this will cause the performance degradation for any kind of services because you cannot guarantee that this is the cluster only for you, right? You will be a multi-tenant cluster that you may have some noisy neighbors that will eat up or fight for the resources, which may cause some performance degradation. So this is exactly what is happening in this case. So we see that the hollow full is actually have a lot of problems with the performance. So what Turbonomic suggestion, which in the back, again, is an economic principle that we find that another provider that is running in Lambda can satisfy the same request, which can provide a better performance. So we suggest that you should move this car full from Knative to Lambda. So on top of that, we actually built this Grafana dashboard to show how the response time looks like before and after the move. So before the move, let's just take a look. So this car full actually has a much higher response time than the car bar, which these data are all coming from Prometheus. So now, let me just run this one more time before I execute this move. So you can see now this car full is actually echoing back hello from edge. Now let's execute this move. See, this happens really quick. So now it is routing to the hello from the cloud. So everything is happening by overriding the label using Istio. So we actually make the decision only and leverage the orchestrator system like Istio to actually performing the corresponding actions that actually can help us to route the traffic. And what happened afterwards? So you can see the performance start to getting much better because that we try to avoid the resource congestion on your Knative platform, which can happen in any edge, that we identify that you have a similar provider, a similar application that runs in a different platform that can give you a much better performance. So this is exactly what we are trying to help. Okay. So this is the demo. So just to summarize, so I hope you enjoyed this demo because we actually spent a lot of time to explore all these technologies and combine them in one demo. And I hope you think this is interesting because I don't think this is an introduction session. What we want to really achieve is that we want to prove of a concept that edge computing can be really, really flexible and can be really, really helpful when you actually try to reach and satisfy your client IoT workload from the edge. But on the other side of this flexibility, it's the complexity. There's a lot of decisions you need to make. So the key takeaways, deploying in cloud is complicated, even the serverless function, because workload needs to be smart. They need to be resizable, scalable, and routable. And take advantage of edge computing. There's a much higher bandwidth and low latency because it's near you, right? You don't have to reach the cloud regions which may be far away from you. You can reach a cell tower which is much closer to you. And real-time decision-making is critical because decision-making today, what I show you today is really only about congestion on the underlying infrastructure. But in reality, the scenario can be much more complex. The performance is what I show you today. And later, you may actually consider what about the cost efficiency. As I mentioned that cross-region data transfer is very costly. So at the same time, if you actually can route the traffic to avoid these cross-region costs, that may be another criteria to route the traffic differently. And compliance. You may face some data sovereignty problems that you want to move the workload routing the traffic to make compliance work. So on top of the demo we are showing you today, next we are going to add more dimension in the decision making. As I mentioned that there is compliance, cost efficiency. Also we want to introduce the micro move, which means that we are not going to route the entire traffic from one application provider to another application provider. We want to do a more fine-grained routing, which is like partial traffic, 90% or 80% to another platform to give you a better performance and cost efficiency, and which is also leveraging Istio as the orchestrator. So thank you. So that's my presentation.